Hello, and welcome to the video portion for the Surfaces Lab of ME123. Today, we're going to have a brief introduction to surface modeling. Up to this point, we've been modeling entirely with solids, objects with a known inside, known outside, and a known boundary. Surface modeling uses 3D surfaces, which can be imagined as rigid sheets. Surface modeling is a very different approach to what we're used to, so this is just going to be introducing the subject. But it does allow for some very unique geometry to be produced. First off, a little bit of information on how SolidWorks operates under the hood. SolidWorks doesn't actually produce solid objects. It only keeps track of their surfaces. It ensures that each object you create is watertight, meaning that the surfaces that make up the object don't have any gaps. Essentially, if the object were to be filled with water, none of it would spill out. All of the features that we've been using are actually a combination of several surface modeling tools, each one stitched together and polished to increase user friendliness. This is great for most applications. But on occasion, there might be a situation where producing the part using surfaces could be easier, or provide more control over the resulting model. For our purposes, I'm going to focus on some things that you can only do with surface modeling, or at least are considerably more difficult without it. If you are interested in learning more about this process, I recommend checking out SolidWorks' official YouTube channel, where they go in-depth on the different surface modeling tools. But for now, let's get started. First off, accessing the surface modeling tools. They live in several places. Generally, you can find them under Insert, Surface. However, it can be a bit of a pain to go back and forth through the menus when you're working with a lot of surface tools, so I'm going to show you how to bring up the toolbar. You can do this by right-clicking on the ribbon, going to Tabs, and then selecting the Surfaces option from the context menu. Unfortunately, you're going to need to reactivate the toolbar every time that you want to do surface modeling on the VM, but it's still considerably easier than digging through the menus to find the tools. Many of the surface tools are similar to the solid tools that we've already covered. You can extrude a surface, you can revolve a surface, you can sweep and loft surfaces, but there are a couple of features that are unique to surfaces. For the purposes of today's lab, I'm going to focus on the sweep and loft surfaces, and then we can talk about how to use them from there. I have a couple of pre-drawn sketches to save us some time, but we're going to go through everything that's special about them as we get to them. Let's begin with sweeps. We can think of the surface sweep as being similar to thin features. Actually, that's pretty much exactly what they are. Just infinitely thin features. Here we can see that we can sweep an open profile along this curve here as our guide path, and that's going to give us a 2D surface that follows this smooth curve. We can see that surface sweep has all of the same options that we had with standard sweeps, but for now we're just going to stick to the standard options. Next up, let's do a lofted surface. This pretty much works exactly the same way that you would expect a thin loft to function. We can select these three open profiles, and then after we have them selected, we can even choose this bottom ellipse here to act as a guide curve. To wrap up this feature, we can just check the Close Loft box in order to enclose the entire shape, and then we can hit our check mark. This brings up one of the first quirks of surface modeling. These surfaces are intersecting one another, but they don't really seem to mind or even acknowledge one another. We can see up here that we have two surface bodies, which sounds pretty similar to having multiple solid bodies. When working with surfaces, we can leave them all disconnected until we're ready to start stitching them together. Thinking of which, now that we have the two basic surfaces that we wanted, let's get started by getting rid of some of these extra bits. We can do that using the Trim Surface tool up on the ribbon. This is unlike anything that we've used before in solid modeling, so let's take a moment to look it over. We've got two types. Standard trimming uses a single surface as the boundary that we can then trim any other surface that it intersects with. Mutual trimming uses each surface to trim the other. We're going to set this one to mutual trimming, and then we can select both of our surfaces. Next up, we can choose to either select which components we want to keep or which ones we would like to remove. In this case, the ones that we want to keep is slightly easier, so I'll leave this button selected, and then we can activate this box to choose this surface and this surface. We can then change the preview options to actually see the surfaces that we want included, and that looks pretty much right. There are a couple of more advanced options that we can use, but I'm going to leave those be for now. Now that we have our trims done, we can hit our green check mark to take a look at what we have left. We can see that the two surface bodies that we had before got merged into a single surface body. However, if we take a look at the underside, we can see that it is still hollow. Let's add in a patch to fill this last section. We can do that by using the Filled Surface option. This feature takes the boundary edge that we select, and it covers the entire gap like a sheet of cling wrap. However, we do still have a couple of options to play with. Contact is going to ensure that the new surface touches the boundaries. We can set this also to be tangent, which is going to ensure that the new surface matches the first derivative, and we can set this to curvature to have it so that the new surface matches the second derivative. These two options don't always work, but the contact is generally fairly reliable. Continuing down the menu, we can select which edges the conditions apply to. If you only have one edge, it's going to apply to all of them automatically, but since we have two, we had better check this box just to be safe. Continuing down, we have the Constraint Curves option, which acts very similar to guide curves for lofts. This ensures that a surface touches any point or curve that we give it. Finally, down in Options, we have the important ones for this tool. Fix-Up Boundary should always be checked. It helps get rid of small gaps or errors in the surface. Merge Results should also be checked if you want this surface to connect with the other surfaces. Let's continue with it unchecked for now, and then we can come back to it later. Create Solid only shows up if the fill surface would make our surface watertight, and if we have the merged box checked. Anyway, leaving Merge unchecked, let's hit our check mark to see what we get. We can see that we have two surface bodies again. One of them is covering the trim, and one of them is covering the fill. We can also see that even though the whole shape is covered and looks solid, taking a section view shows us that the inside is still hollow, so we still have some work to do to fill in our shape. I'm going to show you the more involved method first, then show you the decisions that we could have made that completes this model faster. From here, we need to first connect our two surfaces together, which can be done using the knit surface command. From here, we just select the surfaces that we want to connect, and then we can see that some new options show up. First, Create Solid. That sounds promising. Next down is Merge Entities. We'll want to check both of these boxes to combine the two surfaces into a single surface body, and then turn it from a watertight surface into an actual piece of solid geometry. Now that this is done, we can hit our check mark and take another section view. We can see that we no longer just have a hollow shell. We're left with our one solid body, no extra surface bodies floating around. Let's quick go back to show the easier way to produce this model, and then go about what else can be done with surfaces. In order to do this, I'm going to delete our surface knit feature, and go back in and edit our surface fill. At this point, we can then check the Merge Results box and hit Create Solid. Apply our changes, and now when we take our section view, we can see that we're right back at where we were, one feature lighter. This model can now be treated just like anything else that we've made. The faces can be used as starting or ending conditions, we can cut through it, and we can apply patterns to it. We just need to make sure that we always find a way to solidify the surface before we do any solid modeling with it. Oftentimes this can be done via the Knit tool, or when you're adding on the last few touches with the Surface Fill tool. Let's look at another way to solidify a surface. We've covered just filling the whole thing, but we can also apply a shell-like thickness. I'm going to go in and delete my surface fill, and then we can go up to the toolbar to find the Thicken option. This operates very similar to shell, but it adds material to an outer surface, rather than subtracting material up to a given offset. From here, we can select the surface that we want to thicken, specify our desired thickness, in this case let's do about 1 millimeter, then tell it how we want it to use the surface. This operates pretty much the same as Thin feature. We can choose to have it use the input as the outside surface, as the inside surface, or as a central surface, thickening in both directions. And with that, we've covered a lot of the basics of surface modeling. I hope that you found it useful, and as always, the best way to learn is through experimentation, so feel encouraged to explore all of the surface tools to find out what works best for you. Have a good day, we will see you again next time.